Well, happy days. It's Mr. Thompson with a maths video lesson. Talking about probability still, and this conditional probability, which carries on from my last video about dependent events in particular. So specifically about dependent events and some calculations, terminology, notation, that kind of thing around this sort of stuff. So here we go. Conditional probability, like I just said, is a thing that we talk about with dependent events. So if you need to review that, go back to my last video. And there is a language that we use, and we use the word given. So it's like given that one thing has already happened. So if we look at a set of dependent events where one thing depends on the other or is changed by the other, we look at a situation like that and we assume that one of those things has already happened. Okay? So for example, the probability, finding the probability that that we draw a heart out of a deck of cards, given that a heart has already been drawn previously. So what are the chances of drawing that second heart if we've already drawn one? Okay, so let's talk about that. So first of all, the notation. Okay, that example, by the way, follows on from that last video I made. So the notation looks like this. We have the PR, or it might just be a P sometimes with brackets, or if you call those parentheses. And then we've got that line down the middle, okay? Line, in case that was confusing. And the letter that comes after the line is the event that has already happened when we write it like this, okay? So what we say here is this is the probability of B given A. So what is the probability of B happening if A has already occurred, right? If it's already happened, okay? And there's a calculation, there's a formula for this, and it's but straight up, the probability of B given A is the probability of the intersection of A and B, or the probability of A and B divided by the probability of A. And if that seems random, that's fine, or you might be able to look at that and go, oh, actually that makes sense. If you can't quite see it yet, stick around for the Venn diagram example I'm about to do, and hopefully you'll see why, oh yeah, this actually makes a lot of sense. And of course, there's a little note that the probability of A has to not be 0. And that sort of makes sense as well. If we're assuming that A has happened, well, the probability is not going to be 0, right? Okay, well, let's look at an example. All right, and in this example, this first example, not the Venn diagram one, it's coming later. This one, we're just given a bunch of numbers. It just says probability of A is 0.3, probability of B 0.5, probability of A union B is 0.6. Okay, now notice that is not the thing that we just plug straight into the formula for the conditional probability. This is the thing we plug into that formula that we learned on the previous page. So we're, in this problem it says find this first. Well, you have to find that if you want to get the conditional probability here. So in order to find that intersection of A and B, we're going to use the addition rule, which again I've covered on a previous video, so check that out. And it looks like this: the union equals the sum of the probabilities of each event minus the intersection. Now, the thing that we're trying to find is this intersection. We know the probability of the union, so we're going to have to do a little bit of algebra and solve this thing. Let's plug in the numbers we know. The union is 0.6. Probability of A is 0.3, B is 0.5, and then the intersection is the thing we're looking for. I'm going to simplify here first. 0.3 plus 0.5 is 0.8, and then you can just kind of, you could sort of go step by step here, but, basically we're going to have to subtract something from 0.8 to get 0.6, which most folks might be able to know that it is just 0.2. So that is the probability of A and B, the intersection of A and B. Okay, so now we can plug that into our formula for the conditional probability. The intersection divided by the probability of A. So we just do 0.2 divided by 0.3, which was that probability of A up here. And we can simplify that to 2/3, right? Just get rid of our decimal point on the top and the bottom. And there we go. That's the answer. Okay. All right, here comes the Venn diagram example. We're going to be given a Venn diagram to find the probability of B given A. And I'm going to do this a bit of a long way first, and then I'll talk about a sort of shortcut and referencing back the formula and how the formula sort of makes sense. Okay, so we want to find the probability of B given A. So I'm going to use the formula, which is we do the intersection divided by the probability of A. So I'm going to find each of those things separately. So the intersection is, there's a 9 here. There's 9 things that are in that intersection. So it's going to be 9 out of the total possibility in the whole sample space, which is 5 plus 11 plus 9 plus 15, which is 40. Okay? So 9, 40. Let's can't simplify that. We'll just leave it like that for now. The probability of A, we're going to look at everything in the circle of A, so the 9 and the 11. So that's 20 things out of, again, our total of 40. That we can simplify to 1/2. Okay? Now, in order to find the conditional probability, I'm going to do that intersection divided by 1/2. So I'm going to write it like that. I can, of course, flip over my second fraction, turn it to a times problem, simplify by canceling the 2 and the 40, and the answer I get is 9/20. Okay? Now, if we look at that answer, it should be fairly obvious that, you know, if A has already happened, you know, that's what this whole thing is explaining. You know, what are the probability if we know that B has happened? Well, we can just look at A and say, well, there's 20 things in A, and 9 of them include B as well. So it's 9/20. So you don't probably need to go through so much writing stuff down as what I did here before and do the whole, you know, division of fractions and stuff like that. You can just say, well, look, it's 9 out of the 20 in A, and that's a little bit quicker, but it works either way. And if you just like following formulas, then go for your life and enjoy. Let me know if you have any other examples that you want to see a video of or whatever, and take it easy.